Okay, everybody, here's another example. We want to solve this inequality. 2x squared minus x minus 10 is less than or equal to 0. We're going to follow these steps as we illustrated before. That to solve an inequality, first of all, we set the inequality to 0, which it already is. Then we're going to find all of the linear factors. So we need to factor this thing apart. Now, in this case, this is actually a pretty easy direct factorization. I'll just run through the numbers right here. Remember, we're going to have, by the FOIL method, 2x and x as our first terms here. And we say, well, what factors do we have of negative 10? Whose sum, when we put it in here, is going to give us the same thing as negative 1x. Well, I would say that we have to have 5 and 2, and the reason is that if we take 2 times 2, we would get 4, and 5 times 2 is 10. Now our only question is about signs. But we have negative x right here, so we have to have a negative 5, and we would have to have a positive 4. And again, you can check. 2x squared plus 4x minus 5x gives us negative 1x minus 10. So that's less than or equal to 0. So we're going to mark these zeros on the number line. So I'm going to go through and I'm going to mark out where I have my zeros. So here's 0, 1, 2, 3, 4, 5 off to the right. And let's go off to the left in the same sort of manner. Negative 1, negative 2, negative 3, negative 4, right? So where are the zeros? Well, the zeros, remember, are going to be where 2x minus 5 is equal to 0. So if we solve for that, that's 2x is equal to 5, which is to say that x is equal to positive 5 halves. So on my number line, I'm going to go ahead and I'm going to mark off 5 halves, which is 2.5 right here, right in between. And of course, with the other one, it's a little bit easier. X plus 2 is equal to 0 at the point where x is equal to negative 2. So I'm going to go ahead and mark that on my number line. Now what this does is this divides up the number line into 3 test intervals, is the way that I think about this. Our test intervals, the ones we're going to test, are going to be from negative infinity to negative 2. And we might possibly include negative 2 because we're using the less than or equal to symbol. We're going to have negative 2 to positive 5 halves as a potential solution interval. And we're going to have the set from 5 halves, including 5 halves, all the way up to infinity as a test interval. So what we should do is, in order to test these, we're going to pick a number from within these intervals in order to check. Any number from inside this interval from negative infinity to negative 2 would, if it's true, would show that that entire interval is true. So let's pick a nice easy one like negative 3. And let's see if it makes the original inequality true. So we're going to test x equals negative 3. What happens at negative 3? Well, we would be getting 2 times negative 3 squared minus negative 3, pardon me, negative 3. Let's see if I can straighten that out a little bit. Minus 10. Is that less than or equal to 0? Well, let's see, 2 times 3, negative 3 squared, that's 2 times 9, that's 18. Minus negative 3, that's plus 3, minus 10. Less than or equal to 0? Well, no, that's false. So this solution interval is not part of the solution. That particular interval is not part of the solution. But let's pick one in here. Let's try 0. Does 0 work? Well, sure. 2 times 0 squared minus 0 minus 10 would be less than or equal to 0 if it were true. And of course, negative 10 is less than or equal to 0. So that makes it true. So that is part of our solution interval. And we should pick another number over here. This is why you have to be very careful with fractions. You have to know where those fractions lie. If we picked x equals 3, would that work? Well, if it works, then 2 times 3 squared minus 3 minus 10 would be less than or equal to 0. But of course, we know that's not true because 18, 2 times 9, minus 3 minus 10 is still a positive number, right? So that's false, and that's not part of our solution set. So our solution set, it appears, is going to be, in this case, the set from -2, including -2, all the way up to 5 halves. Now notice one thing, right? We determine the intervals, we graph the solution sets, and then we write out the interval in set builder or interval notation, whichever one's appropriate. If we were writing it in set builder notation, we would write the set from x, where x is between -2 all the way up to positive 5 halves, right, if we were asked for the set builder notation. In this particular set, notice that I did not test the endpoints. Okay, so this is a very important point right here. When you're testing your solution intervals, note to self, don't test the endpoints. They may or they may not make the solution, solve the inequality, but they won't tell you where the solution intervals are. You must check the solution intervals by checking over numbers from within those intervals to see if it works. Okay, more in the next video.